This is S. Lakshmana Chari, working as Assistant Professor in Department of Cyber Security, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss the topic Central Processing Unit (CPU) organization in the subject Computer Organization and Architecture. So we will discuss the CPU organization. So CPU means Central Processing Unit. So already we know. So the computer, it contains three main subsystems that are CPU, control unit, and okay. So the CPU organization. So already we know the computer, it consists of three main important subtasks that are central processing unit, memory subsystem, input and output subsystem. So the central processing unit CPU, it plays a very key role. Okay, so without the CPU, we cannot perform any operation inside the computer. So computer means the computer is an electronic device that can be programmed to accept input, process it, and then it generates the results. So the CPU, it can act as the brain of the computer. So it will be treated as the brain. So because without the CPU, we cannot perform any operation. So that's why it can be treated as the brain of the computer. And the CPU, it performs all the different calculations, and it performs many operations inside the computer. And also the CPU, it controls the entire computer. It controls the different components or enter the computer. And the CPU, mainly its task is to execute the instructions. So first, before executing the instruction, the CPU has to fetch the instructions from the memory. So fetching. So CPU first, it will fetch the instruction from the memory. So fetching is nothing but retrieving the information or retrieving the instruction from the memory. So program is nothing but a set of instructions. So the program generally, it will be stored in the memory. So from the memory, the instructions will be fetched. So and also it supplies the address and control signals that are needed by the memory. Okay. So after fetching the instruction, then the CPU has to decode the instruction. So decode is nothing but interpreting the instruction. Interpreting means here in the decoding phase, the CPU will decide what type of operation it has to perform. So that is a decoding. So after fetching, the next phase is the decoding. Okay, and coming to the third phase. So third phase is the execution. Once the instruction is decoded, then we have to execute. We have to execute the instruction. Okay, so it performs some operations internally and supplies address, data, and control signals needed by the memory and I/O devices in order to execute the instruction. Okay, and nothing happens in the CPU unless the CPU causes it to happen. So without involvement of the CPU, no task will happen inside the computer. So already we know the CPU has three parts that are ALU, arithmetic and logic unit, and control unit, and the last one is the registers. So these are the three essential parts or components of a computer system. So if you look into the internal structure of the CPU, so it is a CPU organization. So CPU consists of mainly the ALU, arithmetic and logic unit. So that means this ALU, it performs different arithmetic and logical operations. Arithmetic operations like addition, subtraction, multiplication, division, increment, decrement, and similarly the logic operations uh, and or XOR. So these are all the different arithmetic and logical operations that are performed by the ALU. So next unit is a control unit. So control unit. So control unit, it is part of the CPU, and it controls. It is used to generate different timing and control signals, which are required to coordinate all the different modules inside the computer. And the third one is registers, internal registers. So already we know the registers are used to store the information or data. So a register is nothing but it is a group of flip-flops. So flip-flop is a single bit storage element. So using that flip-flop, we can store either 1 or 0. So a group of such flip-flops can be called a register. Okay. So if you look into this ALU, so ALU, arithmetic and logical unit. So it performs different arithmetic and logic operations. Suppose if you want to perform some simple addition, so like some 5 and 3. So you are going to add, you are going to perform the addition between the two operands. So 5 is one operand and 3 is another operand. So we are going to add. So this operation, addition operation, it is performed inside the ALU. So inside the ALU. So these values are taken from the registers. So here you can see the operands are given to the ALU. So then the ALU, it performs the addition operation. Once it completes the operation, then again the result value will be given back to the registers. So this is so once the operation is completed, the results are again stored in the register section. Okay, and this register section, it is communicated with two types of buses. One is the address bus and another one is the data bus. So these are the two buses that are communicating with the registers in order to transfer the data. Okay, so this is a CPU organization of the computer. So this is a processor and memory architecture of a computer system. So this is the internal architecture of the computer system. So it consists of CPU, central processing unit. So already we know the CPU, it consists of three subsystems that are control unit, ALU, and some of the registers. Okay, so these are the three main important subsystems of the computer, and along with some other memory. So that are main memory. Main memory is a RAM. Okay, RAM and ROM and cache memory. Okay, and also this CPU we are connecting with some IO devices, some input or output devices, and also we can connect some secondary storage devices. Secondary storage devices also we can connect with this computer. So this is the processor and memory architecture of the computer system. So we will discuss one by one. So in the control unit, we can see there is a decoder, program control register, instruction register, memory address register, memory buffer register, and IO register, and then different general purpose registers are there, and accumulator register. So accumulator is a default register when you are performing any arithmetic and logic operations. Okay, so whenever we are performing these arithmetic and logical operations, the result automatically stored in the accumulator. So that is the use of the accumulator register. So next we will see the one by one. So already you know the ALU. So ALU, it performs arithmetic and logical operations. So here in the ALU unit, the main execution will take place here only. So here the execution. Suppose if you are performing any addition, subtraction, multiplication, so all those operations will be implemented or performed here in the ALU unit. So this ALU unit, it consists of a complicated set of logic circuit, because the ALU, it performs multiple operations. So that means multiple operations it is performing. That means inside that there is a complicated logic circuit is present. Okay, and also it consists of some registers and accumulator to carry out all the operations that are depend on the commands given by the control unit. So commands given from the control unit, that particular operation will be performed by the ALU unit. Okay. And next one is a control unit. Control unit. So this control unit, it selects the programs and coordinates their execution. Okay. So because the computer, it consists of multiple modules, multiple subsystems. So in order to work properly all these subsystems, it requires some controlling signals, controlling and timing signals. So all these different timing and control signals are generated by the control unit, and it regulates the timing of the processor, and it sends the control signals to and receives control signals from peripheral devices, and it acts as the central nervous system for all other components, and it obtains instructions from memory, interprets the instruction, and issues the signals to the required unit to carry out the execution. Okay, so this is a control unit. And coming to the another section, that is the registers. Okay, so the registers in processor, in a processor instruction set architecture, are found in this section. So this in this register section, it contains the processor's instruction set computer. So instruction set computer, instruction set architecture, it is acts as a interface between the hardware and the software. So this instruction set architecture will decide the what the computer will do and how it will do. Okay. Next, the system address bus and data bus interact with this section of the CPU. So already we have seen the internal organization, CPU, internal CPU organization. So there, the CPU, the registers are interacting with the address bus and the data bus, and also it contains the registers which are not directly accessible by the programmer. So some registers are directly accessed by the programmer, but some registers are not. So even that the registers that are not directly accessed by the programmer, also this register section it contains. And relatively a simple CPU, it includes registers. It includes registers to latch the address being accessed in memory and a temporary register. The other registers that are not part of the instruction set architecture, that also contains the register section. So that means the register section, it contains the registers of the instruction set instruction set architecture, and also the registers which are not related to the ISA, also this register section contains. And if you come to the types of the registers, so the registers are classified into the two types based on their purpose. So that are general purpose registers, and another one is the special purpose registers. So general purpose registers are, it can be used to store some temporary data. But the special purpose registers, it is having some specific for purpose for using that particular register. So that are decoder, program control register, we can also call program counter, and memory address register, memory address register, memory buffer register, we can also call memory data register, we can also call MDR, MDR or MBR, and instruction register, IO register, and finally the accumulator. So these are all the different special purpose registers. So we will have a look one by one. So first one is a decoder. So this decoder, it interprets the instruction to be executed. So it interprets. Interprets is nothing but it is deciding what type of operation it has to be performed. Next, the program control register. Program control register. So this we can also call program counter. We can also call program counter. So what it will do? So the program counter always it holds the address of the next instruction is to be executed. So it holds the address of the next instruction is to be executed. Okay. So basically the memory in the memory we will store the programs. So program means a set of instructions. So set of instructions is called program. So if you look into the memory, so the memory will be, it looks like this. Okay, it contains multiple memory locations. So if you see the address, the starting address of this memory, let us assume 2000, and next one is 2001, next 2002. Like that, every memory location it contains some address. So using that address only we are accessing. So without address we cannot access the memory. So see here. So suppose if the instruction present in the 2000 location is executing. So when the instruction in the 2000 location is executing, at the time the next the address of the next instruction, that means this is a next instruction. So that the address of the next instruction is it is a 2001. So this 2001 it will be stored in the program counter. So program counter it holds the address of the next instruction is to be executed. So after executing this the instruction which is present in the 2000 location, the next instruction will be executed. So the next instruction address the next instruction is available in address 2001. So that's why the program control register or program counter which holds the address of the next instruction is to be executed. And in case of branch instruction, the system passes the address part of the branch instruction to the PC. That means a program counter. So basically the program will execute in a sequential manner. So first the instruction in the 2000 will be executed. Next the instruction in the 2001 will be executed. Next the instruction in the 2002 will be executed. So like that all the instructions in a program will be gets executed. But whenever if you have a branch instruction means instead of going to the next address, it is going to the program control is transferring to a new address. So let's assume some here in the third instruction we have a jump 2500, jump 2500. So this jump is a branch instruction. Branch instruction means instead of going to the next address, it is going to a new address which is specified in the address specified in the address part. Okay, so here in the address part, the address specified is 2500. So that is the address specified. So what will happen whenever this jump 2500 instruction is executed, the program control will be transferred to a new address. So that is let us assume this is a 2500. So directly from from this address, here we are transferring to the 2500. So actually after completing the 200 location, next the instruction which is in the 2003, it has to be executed, but instead of going to the 2003 location, it is going to the 2500 location. So in this way, the program counter always it stores the address of the next instruction is to be executed. Next, memory address register. Memory address register. So memory address register. So it holds the address of the active memory location. Active memory location. So or it holds the address of the currently executing instruction address. So that means suppose if you to see in the 2000 location, so we have a add AL comma BL. So it is a one assembly instruction that is present in the 2000 location. So whenever the first instruction is executing add AL comma BL, then that corresponding address, that corresponding memory address, it will be stored in the memory address register. That means for this add AL comma BL, what is the address of this instruction? The address is 2000. So that 2000 address, it will be stored in the MAR, memory address register. So MAR, it holds the 2000 address. So this is a use of this memory address register. And coming to the memory buffer register, memory buffer, or we can also call the memory data register. So it holds the content of the accessed memory word. So that means so it holds the content. So that means in that particular location there is a data present. So that data will be held by this memory buffer register or memory data register. So we are calling memory data register because it holds the data. It holds the data. So that's why it is called memory data register. And it holds the data word when it is transferred to and from the main memory. And coming to the instruction register. So it holds the instruction being executed. It holds the instruction being executed. That means if you look into the previous one, this one. So in the 2000 location, what is the instruction stored? The instruction stored is add AL comma BL. So that is the instruction that is stored in the 2000 location. So that instruction, it will be stored in the instruction register. So instruction register, it contains the currently executing instruction. Okay. So what the instruction register contains? It contains or it holds the instruction being executed. That means an instruction which is currently executing, that will be stored in the instruction register. So if you look into the instruction mainly it consists of two parts. The first one is a operation part and second one is a address part. So the operation part of the instruction will be given to the memory address register, and the address part of the instruction we are giving to the decoder in order to decode the address. And next one is a IO register. IO register, input or output register. So using this register, it is used for communication with the IO device. Because with the computer we are connecting different input or output devices. So from the input device we are taking the input data, and after processing the CPU, then that processed results or output will be given to the output device. So in order to communicate with the input or output devices, we are using this IO register. So whatever the input data coming from the input device, that will be stored in the input register. From the input register, the data will be taken by the CPU. Then it will process, and then it will be given to the output devices. So mainly the IO register, it can be used to store the data. And an input unit transfers all the content to this register, and then the system picks up the data and vice versa. And the next one is a accumulator. So the accumulator, it holds the data under execution, intermediate results, and the result of the operation. Okay, so this accumulator, it is a very important register in the register section, because the accumulator, it holds or it stores the data under execution, and also it stores the intermediate results. That means suppose if you perform any operation, add AL comma BL. So add AL comma BL. That means A is the accumulator register. So when you are adding the contents of one register with another register, automatically the result will be stored in the accumulator itself. That is, accumulator is a default register. Once the ALU performs any operation, finally the result will be stored in the accumulator itself. Okay, so that is the use of this accumulator. So the accumulator, it stores the data under execution, and it stores the intermediate values or intermediate results, and the final result of the operand. So that all will be stored in the accumulator register, and the result, it will be stored in the accumulator. From the accumulator, we can store it in the memory buffer register. From the memory buffer register, finally we will store the results in the main memory. Okay, so this is about the accumulator register. And coming to the memory, so main memory. So here main memory. So main memory. So RAM, random access memory, it can be considered as a main memory. It is a main memory. So main RAM means a random access memory. So using this, we can perform either read operation or write operation into the memory, and it is a volatile memory. It is a volatile. So volatile memory means when the power supplied to the memory chip is turned off, then the content of the contents stored in the memory gets erased. So that is called volatile memory. That means when power fails, the data stored in the memory gets erased. So such type of memory is called volatile memory. So RAM categorized into the this volatile memory. And every file or application opened is placed in the RAM. So if you are open any file or any application, that will be opened from the RAM only. Okay. So defaultly that the program or softwares that will be stored in the some hard disk. But whenever you are opening any file or any application, that files or applications will be copied from the hard disk into the main memory, and from the main memory that particular file or application will be opened. And it uses a random access technique. So random access technique. So random access. So as the name it specifies, random access. That means the memory it contains. So memory means already we know it contains multiple memory locations. So in a memory, so we are going through a sequential approach. That means first 2 3 0 0 location. That means starting from the starting address. Next address 2001, 2002. So that means it is happening in a sequential, one after another. So in order to reach a particular memory location, we have to go through all the memory locations, sequential memory locations. That is a sequential access. But here we are using a random access. So random access is here no need to go through all these sequential addresses. So directly we can jump into the required address or required location. So that is a benefit of using this random access memory. So this random access technique is the data directly jumped to the middle if necessary without having to read the data sequentially. So that means instead of go through all these sequential locations, directly we can go to the required memory location. So that is a random access technique. So here two types of RAMs are there. One is a SRAM and another one is a DRAM. So SRAM means a static RAM, static random access memory, and another one is a dynamic random access memory. So these are the classification or types of the RAM. So in detail we can discuss in the topic memory subsystem organization and interface. And coming to the another memory, that is called ROM. ROM means read only memory. So using this particular memory, we can only perform the read operation. We cannot perform any write operation into this particular memory. So read only memory, as the name specifies that we can only perform the read operation with this memory. We cannot able to write the data into this memory. And these are non-volatile memory. These are non-volatile. So non-volatile means even the power fails to the chip, then the content stored in the memory, it stays forever. That means we will not lose any data, even the power fades. So that is a non-volatile memory. Non-volatile memory means the contents of the memory will not lose even if the power fails. And the instructions are stored by the manufacturer. So in this type of memories, the programs and the instructions will be loaded or will be stored by the manufacturer during the manufacturing. So that means suppose if you consider any home appliances like some television or microwave oven, refrigerator, air conditioner, so all these. So inside that we are using this ROM, okay, read only memory. That means suppose if you consider a microwave oven, inside there we are using some ROM. So in that ROM there is a program. So that means once that program, the microwave working program, it will be stored by the manufacturer. Once they have loaded the program into this particular ROM memory, the user cannot modify or user cannot reprogram. So that is a ROM, read-only memory. And it stores the bootstrap program. It stores the bootstrap program. So bootstrap program is it is nothing but it is a program required to start the computer. And the special programs are stored called micro programs, which deal with low-level machine functions. So the physical structure of the ROM, it can be, it looks like this. It will be. So it is, these ROM chips are available in the form of these ICs, integrated circuits. And coming to the types of ROMs. So we have different types of ROMs are there, that are MROM. So MROM means masked read-only memory. Masked. So masked means so this MROMs are oldest type of ROMs. That means here the programs are already stored. The programs and the instructions are stored in this MROM during the manufacturing. So the user cannot write, cannot modify or cannot reprogram. So these are inexpensive memories. Okay. So these are the masked ROMs, masked read-only memory. That means these are oldest type of ROMs, and once the manufacturer loaded the programs and instructions into this MROM, the user cannot modify. And coming to the PROM, programmable read-only memory. Programmable. So that means here in this PROM, the programs and instructions can be modified once. So only one time we can modify the contents of the memory. That means the user can buy a blank or empty PROM from the manufacturer. Then we can write a program into that. So once we have loaded the program into the PROM, we cannot modify the program. So that means it is a one-time programmable, only one time. Okay. The next one is a EPROM. So EPROM means erasable and programmable read-only memory. So that means here, using this memory, we can programmable, we can rewrite the program, and we can erase many times. That means many times we can write a program into this memory and we can erase. So like that, many times we can perform. Okay. And also we can erase this. Okay. So this erasable programmable read-only memory, so we can erase by exposing this EPROM into the ultraviolet light by approximately 40 minutes of time. Okay. So we can erase the content by exposing the EPROM to UV light. So about 40 minutes. So by exposing this EPROM into the ultraviolet light for about 40 minutes, then the data stored in this chip we can erase totally. Okay. And coming to the electrically erasable EEPROM. So EEPROM means electrically erasable programmable read-only memory. Okay. So in this electrical erasable programmable read-only memory, so we can erase the data using the electrically we can program and we can erase the entire data. So in this EEPROM, we can erase the data at a very less span of time. That means around some 4 to 10 milliseconds. So with 4 to 10 milliseconds of time, we can erase the entire memory chip. Okay. And also here in this EEPROM, when you are programming, that means when you are loading any program into this EEPROM, only we can store 1 byte of data at a time. So only we can store 1 byte, 1 byte of data, 1 byte of data into the memory chip. So this EEPROM, we can program, we can erase the data, we can reprogram. So like that, approximately we can do 10,000 times. 10,000 times we can erase and we can reprogram the memory. And the last one is a flash memory. Flash memory. So flash memory is the advanced version of the EEPROM. EEPROM. So it is a advanced version. Okay. So these are the different types of the ROMs. And next one is a cache memory. So cache memory is a extremely fast and small. So it is a fast memory, but the capacity of this cache memory is very small. That is around some kilobytes or megabytes. So that means it is having very less capacity, but it is a faster. So this cache memory we are placing between the CPU and the main memory, because the CPU, it works with a faster speed, but the main memory is somewhat slower than the CPU. So there is a mismatch in speed between the CPU and the main memory. In order to match the speeds, or in order to synchronize the speed of the CPU and main memory, in between them we are placing a small amount of memory, that is nothing but the cache memory. Okay, so this cache memory we are placing between the CPU and the main memory. And in this cache memory we can store a temporary storing active data. Temporary storing active data. So, and for minimizing the data fetch time. Okay, so for minimizing the data fetch time. So that we will see with the diagram. So usually in the computer we will store some softwares. Okay, software is nothing but a collection of programs. Program is nothing but a set of instructions. So all that set of instructions that will be stored in the hard disk. Okay, so the softwares or programs which are present in the hard disk are executed by the CPU. So central processing unit will execute the softwares or programs which is present in the hard disk. So is the CPU will directly access the programs or software from the hard disk? No. So it cannot directly access. So the CPU can access that softwares and programs through the main memory. So this is a main memory. So the contents of the programs or softwares which is loaded in the hard disk will be loaded into the main memory. So from the main memory the CPU will access. Okay. So from the main memory the CPU will access. Okay now. So but here the CPU speed and the main memory speed is they are different, because the CPU can execute the instructions at a faster rate. That means it can execute million instructions per second. So when you compare the speed of the main memory with the CPU, it is somewhat slower. So there is a mismatch in speeds between the CPU and the main memory. So what we are doing? So we are placing a small amount of memory. We are placing a small amount of memory between the CPU and the main memory. So that is nothing but the cache memory. So this cache memory will synchronizes the speed of the CPU and the main memory. Okay, so this will match. So the cache memory will synchronize the speed of the CPU with the main memory. Okay, so what is the use of the cache memory? So see here. So when the CPU wants to execute any programs, so it will not access directly from the hard disk. So first that programs will be loaded into the main memory. From the main memory, then the CPU will access. So suppose if you have multiple instructions are there. Instructions 1, instruction 2, and instruction 3. So when the CPU executing the first instruction from the hard disk, then that will be placed in the main memory. Then from the main memory, the CPU will execute. After that, the second instruction. Next, third instruction. So in this way, all that instructions from the hard disk will be loaded into the main memory whenever the CPU is executing. Okay, but if the CPU wants to execute the instruction 1 again, so the CPU wants to execute the instruction 1 again. So the CPU will go to the main memory again? So no. So here that CPU, that instruction 1, it will be stored in the cache memory. So from the cache memory, the CPU will access it. Okay. So that means here it will, by using this cache memory, it will reduces the execution time, because the CPU no need to go to the main memory and the hard disk. Okay now. So that means the cache memory, it always holds the frequently used data. That means the instruction here in this scenario, the instruction 1 is executing more times. So that's why that frequently used data that will be stored in the cache memory. So when the next time the CPU wants to re-execute that instruction, it is no need to go to the main memory and the hard disk. So the CPU can execute that instruction by taking from the cache memory. So in this way, by placing this cache memory, we can reduce the instruction time. Okay, so this is about the cache memory. Okay, so in this lecture, we have seen the CPU organization. So how the CPU, what are the different parts of the CPU, and how all these different sub components are working. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.